All right, we're going to start lesson 5.3. This is on linear relationships and bivariant data. So linear relationships, they're just talking about when you have x's and y's, or maybe you have it labeled some other way, that these points form a line. That would be linear. It would be a linear relationship. And bivariant data, so bi stands for two variables. So bivariant data just means like you have an x and a y. There's two variables, and it varies. Sometimes the x is a number and the y is an opposite number, like a table. And so these are like tables. Think of tables or graphs using an x and y. Okay, moving on. Finding the equation of a linear relationship. You can use the points on a graph of a linear relationship to write an equation for the relationship. So they're saying that the points they give you on this graph, you can take any two of these points and you'll be able to write an equation. So any 2 points, whether it's on a graph or on a table, you can use any 2 points to write an equation. Okay, example 1, a handrail runs alongside a stairway. As the horizontal distance from the bottom of the stairway changes, the height of the handrail changes. Show that the relationship is linear, then find the equation for the relationship. So as the distance goes from 0, they're counting by 2.5, 5, 7.5, 10. They're counting by 2.5. As the horizontal distance gets longer, the height of the handrail from the ground, pretend this is the ground, and the handrail is following the steps. And so as the ground distance gets further away, the height of the handrail is higher. Show that the relationship is linear. Well, they gave you these points and they have them labeled here. And if you plot points on a graph and you can draw a line through them, you would say that this is a linear relationship. So the points would fall on the same line, no curves or anything. So the relationship is linear. Then draw a line through the points on the graph. So in your book, they just gave you the points, and if you draw the line, you can see they'll line up. Okay? Okay, now we define the equation of the relationship, and that's on the next page. Okay, so we're going to write the equation of the linear relationship. So we need 2 things. We need the slope, and we need the y-intercept. So for the slope, they chose 5 and 7, 25, 23. Those are points from above, or on your book it's above, on mine's in that previous screen. So keep in mind that we use that formula. Oh, let me see, that would be a y. We start with a y. y2 minus y1 over x2 minus x1. And so here's our y2 number, y2 minus, here's our y1 number, there's y1. We've done these problems several times. Then our x2 number, here's x2. Take away the x1 number, here's your x1 number. So 23 take away 7, and 25 take away 5. Give you 16/20. And you can reduce that fraction, divide them both by 4, and you get 4/5. They took this a step further, and they took the 16/20, and the book actually makes that into a decimal. It doesn't always suit you to make a decimal out of these. Sometimes it helps and sometimes it doesn't. I'm going to show you how using the fraction to explain the problem is easier than using a decimal to explain the problem. But they use this decimal in a good way. They use it to find the b, the y-intercept. So here's your problem, y equals mx plus b. you have to find values for x, y, and m. Now we found m, there it is. And then for x and y, well, x and y is simply an ordered pair. Keep in mind that x and y are simply an ordered pair. Well, so are 5 and 7. And they have a 5 and 7 here. So what they do is they substitute in the y as 7, the y and 7. The slope, they used 8/10, and you could either use 16/20 or 4/5 if you want to multiply by a fraction. Their x was 5, and then they simplify the equation. So you'd multiply here. 8/10 times 5 is 4. And then simplifying, you'd add -4 to both sides. You add the opposite of +4. And you get your intercept as 3. So you have both pieces that you need. You need slope and you need the intercept. And now that you have both pieces, put them together for the equation. If you have 4/5 in here, that would be correct also. They used 8/10. But 4/5 in here, I think, would work better for this problem, and I'll show you why. So from the graph, you have your x and your y, and we said slope was 4/5. Now keep in mind the top number in the slope came from taking y2 minus y1. And the bottom number, of course, was x2 minus x1. And this was the horizontal distance. And so we can say that the horizontal distance was 5 feet. And this was the height. This is how high that the railing was going to be from the ground. Let me just put a graph in here. And so by using two numbers, you can say that every 4 feet that you moved along the railing, it was 5 feet further from the ground. So as this, every 4 feet that this went up, it was 5 more feet from the ground. So 4 more feet, you'd add 5 more feet. If it goes up 4 more feet, 5 more feet. You can actually relate this fraction to the graph. Whereas if you had 8/10 and you were asked to relate it back to the graph, what does it mean in the problem? It's a little harder to do. So sometimes it's good to leave it as a fraction. Sometimes you're better off to use a decimal. Using a decimal is always good if you talk about money. That's always a good spot to use decimals because money is written in decimals. Okay, so this Explore activity, additional example 1, is not in your textbook. It's not in your textbook. And so I found it in the teacher's book, and this is the way it looks in the teacher's book, and it's no other place. And I'm thinking that they wanted me to give you just the points on here, and then you were supposed to draw the line. But I honestly have no idea how I'm supposed to do that because all it is a page in my book. So it is what it is. Okay, so the charge for a pizza changes as the number of toppings change. Show that the relationship is linear and then find the equation for the relationship. Now, one could argue very, very strongly that this should not be connected. I think you're just showing that it would be aligned if you connected them, but we had a problem like this before, and we decided that there can only be whole number toppings. There could be 1 topping, 2 toppings, 3 toppings, and so anything in between these points would not be valid. Again, I think they're just having you look to see how, yes, they would fall on a line. And then that's how you're showing that it's linear. Because you're saying, hey, here's a line, so it must be linear. Okay, so their response for that is, a line passes through all of the graphed points, so the relationship is linear. All right, the next thing I asked us to do, that if it was linear, then find the equation for the relationship. So again, we can pick 2 points, and you can use your y2 minus y1 divided by x2 minus x1. And I'm going to use 211 and 820. Because if I use those, I can work it out so I don't have to deal with that decimal. You know, any 2 points will do. You can choose any 2 points you want. And I'm going to call this one my x2, y2, and this one my x1, y1, because I know I'm subtracting. And if I take a larger number, subtract a smaller number, I'll keep it positive. Little math things that you should know. Use to your advantage. So y2 is 20 minus your y1, which was 11. Well, that's an ugly one. What did I do there? 11. And then your x2 was 8. Take off your x1, which is 2. So 20 minus 11 is 9. And 8 minus 2 is 6. And this is reduced to 3 halves. So your slope is 3 halves. So what causes the slope to increase are the amount of toppings you have on the pizza. The more toppings you have, the steeper this is going to go up. We pay money for toppings. So if I asked you how much are the toppings and you told me 3 halves, that would sound really weird. So what we can do, because we know that we're dealing with money, we're buying this pizza, we can actually put down my slope, or your slope, as 1 5/10. And you'll see how that works off a little bit better. Alrighty, so now we want to find the intercept. So we have our M, now we want to find our B. So y equals mx plus b. I know my slope is going to be 1 5/10. Now you can choose any ordered pair you want here. But again, I'm going to avoid the decimals. And I wanted low numbers. I'm going to use 2 and 11. My x is 2, my y is 11. So my x is 2, my y is 11, and finding b. So let's multiply. 1 5/10 times 2. So 1 5/10 times 2 would give you 3. And then you're going to take 3 away from both sides. The objective here is to solve for b. So subtract 3 from both sides. And b is going to equal 8. So now you have your slope, you have your intercept, you have your equation. What does the 8 mean in this problem? What does the 1 5/10 mean in this problem? So 8 is your intercept. So the price is $8. 8 is your intercept. The price is $8. You could have looked at your graph for that. But if you had mistakenly drawn the line, you may not have hit that 8. So doing the math is actually more accurate because we could make a mistake drawing our line. So if the price is $8 That tells me I have 0 toppings. So the $8 is a pizza, a plain pizza, has cheese, and that is it. Now, as the line increases, the number of toppings and the cost increase. The topping is controlling the price. So the more toppings you put on, the higher the price. Each topping is $1.50. That's what the slope means. The slope is telling us that for every topping, you add $1.50 to the 8 for the cost of your pizza. Okay, as we finished off class today, the students were asked to complete the Your Turn. They were asked to take a picture or email me their answers for problems 1 and 2. And so they would email me an equation. And that's all we covered for Wednesday. Bye-bye.